Okay, let's just dive right into this one. Welcome to today's explainer. We're going to unpack a universal, honestly kind of magnetic trap that literally every developer, coder, or software engineer falls into at some point. And that is the perilous pursuit of perfect code through refactoring. You know the exact feeling, right? You're looking at a piece of code, it works, sure, but it's just a little bit clunky, and you think, I can make this cleaner, I can make it more elegant. But at what point does that pursuit of elegance cross the line into complete obscurity? Well, today we're exploring that exact tension, and we're looking at a very specific, real-world example straight from the Haskell programming language. To really wrap our heads around this, we're grounding our explainer today in a deeply personal, almost diary-like entry from a developer named Ang. This is pulled from part 163 of their ongoing series, Notes on Haskell-Programming. And just notice Ang's phrasing here, Dear Interweb. It's epistolary. It's his honest confession. Ang writes, this is one of those refactorings where I sometimes wonder if the change actually helps. Right off the bat, we're stripped of that usual tech bro bravado, where every single code change is touted as this massive triumph. Instead, we're looking at the raw, creeping doubt that happens when you've manipulated your syntax, you've hit your technical goal, but you suddenly feel like you've lost something essential in the process. So, Section 1, the refactoring dilemma, compact versus readable. This right here captures the absolute push and pull of the refactoring process. On the one hand, you have the holy grail of programming, removing code duplication entirely. Like, if you have the same logic twice, it's a liability, right? And Ang successfully eradicated it. But this massive triumph comes at a pretty steep price, the cost of readability. You've successfully condensed the machinery of your code, but in doing so, you've made the actual blueprint incredibly difficult for a human being to read. Moving on to Section 2, dissecting the syntax. Let's actually look at the mechanics of guards and or operators to see exactly what Ang changed. Conceptually, here is the core trade-off. We're moving away from the old paradigm, case statements. Now, case statements in Haskell, and really in a lot of languages, can be a bit bulky. They spell absolutely everything out. They take up a lot of vertical space. They're basically the scenic root of logic. On the flip side, we have the new paradigm Ang moved toward, guards and logical ors. This approach is mathematically compact. It's sleep. It is the bullet train of logic. But to understand why Ang is second-guessing this bullet train, we need to quickly isolate the two specific tools they use to actually build it. First up, the guard. Represented by that straight vertical bar, a guard is a Boolean expression used in Haskell syntax to evaluate different cases or conditions in a function. You can think of the guard as a literal gatekeeper. It just stands in front of a piece of code and says, okay, are you true or are you false? If you meet this specific condition, you may pass and execute. If not, we move to the next guard. It's an incredibly powerful, native way to route logic in Haskell without having to write out those super clunky, nested if-then-else statements. And right alongside the guard, we have the logical OR, represented by those two vertical bars. In this context, pairing the logical OR with guards lets you smash several different acceptable conditions together into a single line. It gives you the power to take a massive, multi-layered case statement and just compress it down into one highly dense, singular mathematical phrase. All right, Section 3, the cost of compactness and readability trade-offs. So here are the exact tangible steps Ang took during this whole refactoring journey. Step 1, completely tear out the old bulky case statement. Step 2, bring in our new tools, adding those elegant guards and OR operators. And finally, Step 3, the triumphant elimination of code duplication entirely. Now, on paper, looking at these 3 steps, this sounds like a textbook win, doesn't it? It sounds exactly like what they drill into you in computer science classes. You've completely minimized the footprint of your code. Just look at this incredibly compact syntax from Ang's post. It is pristine. It's incredibly tight. There's zero wasted space, no extraneous wording. The logic has basically been folded in on itself using those guards and operators until it's practically a diamond. But as we're about to see, diamonds are very hard. And when you're a developer returning to your own code months later, you don't necessarily want a hard diamond. You want a readable instruction manual. Which brings us to Section 4, elegance versus obscurity and deciphering syntax. This brings us to the real climax of Ang's realization, and it's a pretty profound one for anyone who learns or builds systems. Let's read Ang's exact words again here. Quote, while it's cleaner, I'm still wonder whether it's easier for me to read the code without decipher the guard syntax. The absolute crucial point is that word right there, decipher. Ang isn't just reading their code anymore.
They are actively deciphering it. They've traded the minor annoyance of duplicated code for the real, heavy mental burden of having to decode highly dense syntax. So yes, the visual clutter is totally gone, but the cognitive load, that's skyrocketed. The code is cleaner to the compiler, for sure, but it has become significantly more opaque to the human mind.
Which leaves us with this final, incredibly important question to ponder. Is the cleaner code actually easier to read, or is it just a new puzzle to decipher? When we strip away duplication and compress our logic using advanced syntax like Haskell guards, are we actually making our projects better, or are we just building elegant traps for our future selves? It's a brilliant reminder that, in the world of development, absolute technical perfection and human readability are often pulling in completely opposite directions. Thank you so much for joining me for this explainer. Next time you find yourself aggressively refactoring, I really hope you ask yourself, are you writing an instruction manual, or are you designing a puzzle?